If 5 to the 5x power times 25 is equal to 5 to the nth power, n and x are integers, what is the value of n in terms of x? Now, it might be tempting to try and plug in some kind of number, like 2, or honestly, maybe you could even get away with 1, in for x, and try and compare that against the options here, but you are looking for an exponent, okay? You are looking for the value of n, just this thing. So trying to back solve and plug in numbers might be a little bit confusing. I think at the end of this video I'll give it a try for all you folks who want to see that, but really there is a much quicker and much more elegant way of doing this. So first I will show you method 1, the one that I recommend, which just requires that you remember some rules of exponents. Now, we're going to look at 5 to the 5x power times 25, and apparently it's equal to 5 to the nth power. But we're going to replace 25, because we know some of our common squares, we know that this is 5 squared. We know that 25 is 5 squared. And we know from our rules of exponents, okay, I'll write it down here. It's one of the most important ones, okay? So when multiplying exponential terms with the same base, I should add, but with the same base as these do, like 5, we add the exponents. Okay, so there you go. There's the rule that's going to govern this next step. I am multiplying 5 to the 5x by 5 to the second, and that means I can rewrite this as 5, and when I add the exponents, I get to the 5x plus 2. 5 to the 5x plus 2 is equivalent to this, and is apparently equivalent to 5 to the n. Now that answers the question, okay? In the exponent spot here is 5x plus 2 and n. Therefore, we must conclude that n is 5x plus 2 in the case that the rest of the problem, the bases are exactly the same. So there is your answer. What about this other way I mentioned? Well, this other way I mentioned involves plugging in a number for x to see what this is equivalent to see what power of 5 you actually get. Now let's say I obey the conventional wisdom of the GRE and I don't pick 0 or 1, but rather I pick x equals 2. Now we have 5 to the 5 times 2, or 5 to the 10th times 25, which is equal to 5 to the n. I wouldn't advise using your calculator because it might give up. We still have to use the same trick we used before. We need to express this as 5 squared. And also using tricks from before, also using the laws of exponent, we can conclude that this is 5 to the 12th power. 5 to the 12th power equals 5 to the n. Therefore, we can conclude in this case we made up that n equals 12. Okay, which of these is 12 when x is equal to 2? And that would be this one, right? So 5 times 2 plus 2 is 10 plus 2, and that's 12. So we're right by that method as well. Kind of cool, kind of all right. It wasn't a total disaster, but you've used a lot of there was no getting around some of the rules here, okay? There was no getting around doing 5 squared instead of 25, and there was no getting around the addition of exponents when multiplying by the base. This is just something, this method is something you want to be more comfortable with, for those cases where really plugging in does not work, but in a pinch you can use both. In either case, I think using the calculator would be convenient. Inconvenient. Again, because the calculator does not like large exponents. It doesn't even have an exponent button. Okay, so to run 5 to the 12th power, for instance, and see what that is, that would have you plugging in 5 12 times, and then seeing which power of 5 equals that. Be a little bit strange, okay? So these are the methods I'd recommend using. Definitely try the first one out if you can, and get used to doing things symbolically. Things will tend to go a little bit smoother most of the time.